Hi everyone, I hope you've had a safe and restful spring break. Looking forward to get back to physics. So today I want to talk to you about two big ideas in physics we've been talking about so far. And the first one is the idea that fields affect charges. So far we've restricted ourselves to electric fields. And we've described this relationship by saying that the electric force is equal to the charge times the electric field. Beginning with the last lesson before spring break, we started to begin talking about magnetic fields. And the sort of addendum we need to add in when we talk about fields affect charges, well, electric fields affect charges just because they're there, right? If we look at this equation, we just have the magnitude of the charge and the magnitude of the electric field, and their product is the electric force. Now, magnetic fields are a little bit different. Magnetic fields affect moving charges or currents. And the equation that we're going to use to describe that is F magnetic is Q V cross B. This is for a single charged particle moving at velocity v. Another way that we can write this is the magnetic field affecting an entire wire will be the current of the wire times the length of the wire cross the magnetic field. And I want to just sort of let you remember that this is this cross product is not regular multiplication. This is a cross product. It is a way of taking a vector times a vector and getting a vector. And we'll definitely talk about that a little bit more in a second, but I just wanted to show these equations to you so that you could see them. The second big idea that we have that we're going to be talking about is the idea that charges create, and so far we've always talked about electric fields. And there are two ways that we've talked about this for electric fields. We've talked about Coulomb's law, that the electric field is integral k dq over r squared r hat. Or we've talked about how we've used Gauss's law and said the electric field dotted with the area is equal to Q enclosed over epsilon naught. There's sort of been two ways that we've done this. And there's going to be two ways that we do it for magnetic fields, but again, we're going to have to add in the qualifier for magnetic fields that it's moving charges create magnetic fields. And the equations that we have describing that are that the magnetic field is equal to mu naught over 4 pi integral I dl cross r hat over r squared, and another one that is integral over a closed loop of b dot dl equals mu naught I enclosed. And we'll discuss this more in class, but I sort of want you to see that there's parallels between this equation and this equation for magnetic and electric fields. Instead of our source being charges, our source is currents. And there's also a parallel that you can draw between this one and this one. And we'll definitely talk about these in the upcoming weeks. Well, in the upcoming 2 weeks. So on Tuesday and Wednesday in recitation, we're going to talk about this first rule, that charges that fields affect charges, I should say. And we'll definitely get lots of practice with that cross product. And we're going to be looking at both of these equations. The magnetic force is QV cross B, or the magnetic force is IL cross B. So in this case, we're always going to say, all right, what's the force on a charge given some field, right? The magnetic field will always be given. It'll be, hey, we have a magnet. It'll be, we have some external magnetic field. Never mind how it was created. And that's where we're going to start, by thinking about how these magnetic fields affect the motion of charged particles. On Thursday, we're going to start looking at rule number 2 about charges create fields. Thursday and then Tuesday next week. We will look at both of the equations that we drew on the other page, and we'll start thinking about how we actually go about calculating these things. And then we're going to think about some of the different rules that we're going to come up with, and we're going to find out that not only do fields affect charges by, well, we'll get to that next week. So I just wanted to talk a little bit about the activities we've got coming up in the next few days. Hope you had a great break, and we'll see you in class.